Hello and welcome to this video about Python string object methods. We are excited to have you here, and in this video you will learn to use some intermediate string object methods, or you could say functions, which are used to transform, change, manipulate or test the content inside a string object. These string methods can be used to search strings for defined content, to test the properties of strings, to change or update, and in the process create new string objects. And these string object methods are a great toolbox for data handling, both in terms of managing string data, but also in more general terms, as the string data object often is a transitional data form in various types of data handling. So, in this video we will teach you a collection of intermediate string object methods useful for the purpose of data handling with Python. We'll begin to talk about some string methods used to test the content of strings, tests which may be important when using strings in terms of data handling. And the methods we will learn to use are isAlpha, which tests if a string consists of only letters, and the isDecimal method, which tests if the string consists of only decimal characters. These functions are useful when converting data between string formats and numeric formats for computations, as they can test if the outcome of an operation, conversion, or casting of an object will yield useful results even before the computation occurs, with the possibility of having to catch errors. Similarly, these functions can find lots of data errors and other data anomalies, in particular when loading data files from various unknown or unstable formats. Two other useful tests we will look at are the isLower method, which tests if the characters in a string are lowercase, and we will also look at the isUpper method, which tests if the characters are uppercase. These tests return true if the test is true and false if the test is false. And these tests can be used to test strings for various types of comparisons, as upper letters generate different comparison values than lower letters for the same letter, or they can be used to check and control output and similar items. We will look at some methods for searching the contents of strings, such as the findEx and rfindEx methods, which returns the integer position of a finding of a string x inside a string, or a -1 if no finding is made. Another function is the countEx method, which counts the number of times a string x occurs in the tested string and returns an int describing the number of counted occurrences. These methods are useful to find strings or string parts if there is something to be found, the finding's location in the string, or the amount of times the string occurs in the searched string. We will also look at special methods for changing the contents of strings other than the assignment method, which you already know. So we will look at the capitalize method, which returns a string with the first letter capitalized and the rest lowercase. We will look at the lower method, which returns a string with all letters lowercase. And we will look at the upper method, which returns a string with all letters uppercase. And these methods are extremely useful to fix string text output, or for example in text mining to remove the amount of variation and make texts more equal for comparisons. And we will look at the replace x and y method, which returns a string which have all the occurrences of string x replaced by string y. And this is a method or function which is currently implemented in each and every word processor as the replace function. And this fact demonstrates its usefulness for any text operations. We will take a look at the split method, which is very useful for text analysis in that it makes it easy to split a sentence with multiple words into lists of strings where every string corresponds to a word. We will take a look at the strip lstrip and rstrip functions, which returns strings which have had the white space removed from them at the beginning of the string, at the end of the string, or both at the beginning and the end of the string. And these methods are useful to remove common whitespace additions to texts, which may confound analysis as whitespace, while invisible to our eyes is very real and has a numeric, or you could say string value, to the computer. All of these methods, which we will teach you in this video, are very useful for data handling. So, now we'll start our code editors and type some string code. So let's start up our code editors. All right, having started our code editors, we will start with describing our code. So we type some Python string object methods. And now we'll create some example strings. So we type create some example strings. Example string 1 equals hello. And we'll type that this string is intentionally misspelled in a strange fashion. We will create example string 2 world. And we'll type that string 2 uses uppercase letters. And we will have example string 3, which we will give a comma sign and the text again. And here we can type the comment that we only have lowercase letters in this string. And we have example string 4, which we set to 123.3. And this is a float as a string. And we have example string 5, which we set to an integer 32. An integer as a string. And we have example string 6, which we set to hello world again. And we type an ordinary string example. And we have example string 7, which we just make with a bit of white space. Hello. And a bit of trailing white space. So we call it hello with added white space before and after the visible string. And we have a example string 8, and this is the string or the visible string world with a comma sign and added whitespace before and after the visible string. So let's run this code like this. And now we will make some tests on these strings. Let's begin with some tests on the strings. So we type print string 4, and we can use is alpha. Is it true or is it false? We can print is decimal true or false. And we can print string 5 is numeric. And we can say that it is necessary to keep floats and integers separate. So let's run this code. And here we can see that string 4 is a float created as a string, and it is not alphanumeric, and therefore we get false. And we also tested if it is a decimal number, and because of the dot, it is not. We tested if it is numeric, and because of the dot, it is not. And we tested string 5, which is an integer, and it reported itself as true when we tested if it was numeric. And we can, for example, rerun this code without this dot. And now this is an integer. So let's rerun this code. First this code, and second this code. And here you can see that some of these tests on the string 4, which were false, turned true when the dot was removed. So all right, we will conduct some more tests. So we will type print string 2 is upper. We will print string 1 is upper. And we will print string 3 is lower. So we will first test if string 2 has uppercase letters. And all these letters are uppercase, so it should report true. And we will test if string 1 has some uppercase characters. But here we can see that not all characters are uppercase, so it should report false. And we will test if example string 3 only has lowercase characters. And it has so it should report true. So let's run this code. And here we can see that string 2 is upper, is true. String 1 is upper, is false. And string 3 is lower, is true. So we can say that the tests are defined as native string methods and can be used to check the contents of strings before using, for example, cast methods on them. For example, to convert a string to an int or a float. And this is very useful when considering new loaded data files or to be used as a tool to make certain defined changes to a column or row or a list of strings in a collection. If the test yields true, you convert, otherwise you mark the item or object or row or column or part of a column or row for visual or automatic inspection of the issue. So you can use these methods to control the type of object you want to operate on, and you can use these methods on several string objects in a collection of your choice. And now we'll take a look at methods for searching for content inside strings. So let's type methods for searching for content inside strings. And the methods we will look at today: return integer positions, or you could say integer values, describing the positions of findings, and -1 or a -1 if no findings occur. So we type print string 6. And we print string 6 to have it closer on our screen. So we type print string 6 find world. And this method returns the position of the first item of the first element. And we will type print string 6 or find low. And this will return the last occurrence first element. And we will print find aircraft. And this will yield no occurrence and return -1 or -1. And this code will search our string 6 hello world again for the strings given as arguments to the find or rfind methods. And the method will return the first finding of the string argument given the find method. For world, this will be position 6. For low, position 3. And for aircraft, -1, as the string is not present in string 6. So let's run this code. And the machine returns 6, 3, and -1, which are the starting positions of the string we are looking for. For example, world begins at position 6, which is 0, 1, 2, 3, 4, 5, and 6. And we have no aircraft in the string, and therefore we got -1 with the last piece of the code. So now we'll count the occurrences of a string using the string count methods. So let's type methods can count the occurrences of a string inside a string, and it is important to remember that while a string often is a word, a string can also be a sentence, paragraph, a book, or an entire library, or even more. And this makes the search functions incredibly powerful. So we print string 6, count. The number of else in this string. So let's run this code. And this method returned 3. And here we can see that we have 1, 2, and 3 else. So now we know that the method counted the occurrences of the string L correctly according to the method. And this is an incredibly powerful function to find the exact number of occurrences of a string. And now we look at some methods that can change or replace the contents of a string, or rather create a new copy of the string under transformation. So we type some methods can change or replace the contents of a string or create a new copy of the transformed string. So we type print string 1, capitalize. We can print string 2, lower. String 3, upper. and string 6, replace else with once. So the first line will take the first example string 1 and it will capitalize the first character and make the rest of the characters lowercase. The second line of code will transform this uppercase string to a lowercase string. And the third line of code will convert or transform a copy of example string 3 into a uppercase string. And the fourth line of code will make all the else in our string 6 to be transformed into ones in a new string that will take string 6 place and name. So let's run this code. And here we can see that our first string, example string 1, was capitalized. Our second string was turned into a lowercase string, and our third example string was converted to an uppercase string. And example string 6 had all its else replaced with ones. And now we'll take a look at a method that may split strings into lists of strings. So we will type a method that can split strings into a list of strings. So first we create an example string 10, which is equal to example string 7 plus example string 8. And this creates a new string. And we will print this new string. And we will create a list of strings. And this new list of strings will be equal to the new example string, which we will split. And this method splits a string 10 into subparts. And these subparts are coded to be the words of this example string 10. So we will print the list of strings, and we will make another printout. So we will, for string in list of strings, print string. So let's run this code. And here we can first see our new string, example string 10. And we can see that it has two words with a lot of white space around it. And we created this list of strings with the split method. And this created a list with two strings, hello and world. And here we can see that the split function removed the white space. And we also printed these strings as individual objects without the list. So we can see that the white space are removed from these two new strings. And now we'll take a look at the explicit methods for removing white space and explicitly modifying new string copies, for example, by removing, in this case, white spaces. So let's type methods can be used to modify new string copies. For example, by removing whitespace. So we type print string 10, and we only do this to display string 10 with whitespace. And we remark that e string 10 is equal to e string 7 plus e string 8. So now we will print e string 7 and use the left strip function on it. And we will add string 8 and use the R strip or right strip function on it. And we will print e string 7 and use the double-sided strip on it. And we will add some white space. And we will use the double-sided strip function on example string 8. And here we can comment that here we have a double-sided strip for both strings plus new white space. And you will discover why we add new white space, because these double-sided strips, they remove all white space. And therefore we must be careful to add this white space in this particular case, which we have constructed here. And we will also print example string 10 with the double-sided strip function. Here we will type double-sided white space removal for example string 10. So let's run this code. And here we can see that example string 10 has a lot of white space around the words. And we can see that the left strip and the right strip removes some white space but leaves the white space in the middle, plus that we cannot on the screen see the removed trailing white space regardless if it was removed or not. And that is something to keep in mind for some string operations, in particular when you will compare different strings with each others. Because a string that has white space and a visibly exactly equal string which not has white space trailing or in front of it will be different when you compare them, whereas they may look equal on your screen because you can't see the white space. So right, if we take a look at the 2 times double-sided strip of white space for both string parts, we can see that it looks good. But we remember that we had to add extra white space between the 2 words. So this is the result which we want to obtain. And if we look at the double-sided strip of white space In the last example, we can see that it works, but not for excessive internal whitespace inside the string. And in this case, you have two options. Either you do this operation, or you split the string, which automatically will remove all the whitespace, and then you rebuild it in the same way. So you can rebuild it from this list of strings, but you still have to add this new whitespace. So we can say that controlled and careful splitting of strings tend to yield the most useful results, regardless if you're operating on a text document, social media data scraped from the web, or open-ended questions or other text data. And as the final part of this video, let's type. The applications and usefulness of string methods or functions are near limitless. And this is important to remember. For example, all you see in the news about artificial intelligence and all these applications are effectively about either managing graphics or sound or text and strings. And there are new applications and new usefulness, and you could say a stronger degree of usefulness of these string operations on a monthly basis currently. So, all right, this has been a fun video, and you have learned a lot about intermediate string object methods, or you could say functions. In the next video, we'll teach you even more. And we look forward to see you in the next video.